Assume that a firm is operating in a purely competitive market and that its input output relationship is of the following form. All right, so here, this input output, this Q represents the output, and this x to the power 1 over 3, y to the power 3 represents the input. All right, x x and y are goods. All right, so the number of units of x and the number of units of y, when you place them in this function, it will give you the total output. Okay, so these are our inputs, the x and the y, and q is our output. Okay, so where px equals 1 kwacha and py equals 1 kwacha, there is no fixed cost. At how many units of output q will the firm maximize the net returns when the price of the product PQ is 27 kwacha? So I want to know what output of Q do we need to produce so that we maximize our profit. So here the main thing that we're going to need to do is we need to find the values of X and Y. Once we find those values, we'll be able to see how the firm maximizes its profit. So the first thing that you need to do here is you make a profit function. Why are we making this profit function? So that once we make the profit function, we can be able to determine how many units we need to maximize the profit. All right. So the first thing here, you need to, because there's no marginal cost here and marginal revenue. So we cannot use the marginal cost equals marginal revenue formula here. Okay. We're going to use the marginal profit equals 0. Remember, one of the laws for maximizing profit, you maximize profit when the marginal profit, the additional profit you get when you make an extra good, is 0. This is going to help us know how many units we need to make in order to maximize profit. So if you remember the profit function or the profit equation, profit equals total revenue TR, total revenue, minus total cost. So let's get our total revenue function. If you remember, total revenue TR is equal to price P multiplied by quantity. So the price we're going to use here is this 27 kwacha here, PQ. Okay, 27 kwacha. This is how much we're selling the good for. So 27 kwacha multiplied by. So now Q, we're going to replace it with x to the power 1 over 3, y to the power 1 over 3. Okay, because we've already been given here Q equals x to the power 1 over 3, y to the power 1 over 3. So we substitute that with Q. So you're going to have x to the power 1 over 3 y to the power 1 over 3. This is our total revenue function. Okay. Total revenue function. Any questions before we go further? Okay, then we get our total cost function, TC. So for the total cost, is the price of good X multiplied by the quantity of good X. Remember, X and Y are raw materials. Okay, they are raw materials. Plus the price of good Y times the quantity of good Y. We've been given the price of good X is 1 kwacha, the price of good Y is 1 kwacha. So we substitute PX with 1 kwacha, and you substitute PY with 1 kwacha. So you have 1X plus 1Y. So that is our cost function, 1X plus 1Y. So that's our total cost function. Any questions? Remember here, the name of the game is we want to first find the values of X and Y. Okay. We want to find the values of X and Y. So yeah. So once you've got your total revenue function and your total cost function, you can just substitute it here. Total revenue 27, open brackets, X cubed, and not X cubed, X to the power 1 over 3, Y to the power 1 over 3, minus TC, we substitute it with X plus Y. Simplify this. Twenty-seven x to the power 1 over 3, Y to the power 1 over 3. If you want this 1 over 3, you can also just put it outside the bracket. Okay? Yeah. If you put it outside the bracket, it will still mean the same thing. And also, if you want, you can distribute this 27 across here. Okay? There are a lot of things you can do. Then here, you have to expand this bracket. So you say negative 1 times X, negative X, negative 1 times Y, negative Y. Okay, so this is our profit function. So before I go further, any questions? Remember, we're going step by steps and slowly. Okay. Now, as I said, profit is maximized when the margin of profit equals 0. So we have to partially derive this profit function, because remember, we've got two variables, X and Y. So whenever you see two variables, just know partial differentiation comes into play. Okay, so we're going to first partially differentiate our profit function with respect to X. Right? Meaning where there is an X, where there is no X, that value disappears. And then where x and y are attached, you're just only going to differentiate x only, okay? This is the important thing you need to know. When you're doing partial differentiation, if the variables, for example, if you have an xy attached like this, and you are partially differentiating with respect to x, you will just differentiate only this x, you will leave the y. But if you have like an x plus y, the variables are separate. When you partially differentiate for x, the y disappears. Are we clear on that, colleagues? When doing partial differentiation, if the variables are attached, you only derive one and you leave the other one. But if the variables are separated, especially if you say a plus or a minus sign, okay, usually if you say plus or a minus sign, then the variables are separated, then one of them is disappearing. So in this case here, all right, we have x to the power 1 over 3. So we're just going to derive it here. So remember differentiation, the exponent multiplied by the coefficient. So you're going to have here 27 multiplied by 1 over 3 x. Now we're going to subtract this 1 over 3 minus 1. Okay. So colleagues, 1 over 3 minus 1, whenever you're subtracting a fraction minus 1, especially when the fraction is in front of the 1, you just repeat the denominator on top here. So 1 minus 3, that's negative 2. So we remain with negative 2 over 3 here for x. And then y just stays the way it is, y to the power 1 over 3. Questions? This x also here, we derive it, when you do x to the power 1, we derive it, it just gives you 1. This y, we only differentiating x, so this y disappears. So let's put now this in a proper form. So you say 1 over 3 times 27, that is 9. So you're going to have 9 x to the power negative 2 over 3 y to the power 1 over 3 close brackets minus 1. So this is the marginal profit function with respect to x. So once you get it, you equate it to 0, because remember, profit is maximized when your marginal profit equals 0. So here 9 times x to the power negative 2, 3 y to the power 1 over 3. So write it like this: 9 x to the power negative 2 over 3 y to the power 1 over 3 minus 1 equals 0. Then This negative 1, take it over the equal sign. So you're going to have 9x the power negative 2 over 3 y to the power 1 over 3 equals, when the 0 goes over, it becomes positive, so it equals 1. So this is going to be your equation 1. Next, we need to derive this profit function again, this one here, now with respect to y. So we derive the profit function with respect to y. Here we've got, so the original profit function is 27 minus x minus y. This is the profit function, right? So again, we are deriving with respect to y. So this x, you're going to leave it because they're attached together, these two. So 1 over 3 times 1, I'll just bring it in front here, this 1 over 3, so that we can make life easy, right? Exponent multiplied by coefficient, then you subtract a 1 from the exponent. So you're going to have, when we simplify everything, you're going to have 1 over 3 times 27, 9. X to the power 1 over 3 y to the power negative 2 over 3. This x disappears because we're differentiating with respect to y. Then when you derive this negative y here, it becomes negative 1. So here we've partially derived. So again, you equate this to 0. Right, then you combine this 9 with the x and the y, so you say 9x to the power half y to the power negative 2 over 3 equals this negative 1. When you take it over, the equal sign becomes positive 1. So this is your equation 2. Remember, here we're just trying to find the values of x and y. Okay, we want to know what are our values of x and y. So yes, any questions up to this point here? We formed a profit function. After we formed that profit function, we're partially deriving it with respect to x and with respect to y. Once we derive, we're following the law that you maximize profit when the margin of profit equals 0. Okay, so this here is like your margin of profit where I've put this green dot, that's like your marginal profit. Even here, this where I'm putting this other green dot, this is also your marginal profit with respect to y and x. That's why I'm equating them to 0. So yeah, any questions? So now we're going to use simultaneous equations. Okay, we have to use simultaneous equations to find the value of x or y. So we can work with equation 1. Okay, simultaneous equations begin. So we say 9x to the power negative 2 over 3 y to the power 1 over 3 equals 1. So first, let's put this equation properly. Remember, when a letter has a negative exponent, from the laws of indices, all right, x to the power negative 1 is the same as 1 over x, 1 over x to the power 1. Okay, this is a law in indices. Okay, so we're going to apply it here with this x to the power negative 2 over 3. It's going to come on our denominator here. And the exponent from negative 2 over 3, it becomes positive 2 over 3. And then we still have our y to the power 1 over 3. Remember here, what I'm trying to do is I want to make one letter the subject of the formula. Okay, so I think I want to, yeah, I'll try to make x the subject of the formula. Okay, that's what's happening here. Once we've simplified the equation like this, you can choose. I can either make x the subject of the formula, or I can either make y the subject of the formula. Okay, so here, this is what we're going to do: cross multiplication. X to the power 2 over 3 multiplied by 1, you get x to the power 2 over 3 equals 9y to the 9y to the power 1 over 3 multiplied by 1. Here you get 9y to the power 1 over 3. All right, colleagues, are we okay with this part? Now, we want to make x the subject of the formula. So we need to get rid of this 2 over 3. And how do we do that? We multiply it by 3 over 2. So what you do on the left-hand side, you also do it on the right-hand side. Here, 3 over 2. So 2 over 3 times 3 over 2, it gives you 1. All right? So x remains by itself. Now on the other side here, This 3 over 2, we're going to distribute it to 9 and y. Okay, this 3 over 2, distribute it to 9 and also y. So here we have 9 to the power 3 over 2. Then here we have y to the power 1 over 3 times 3 over 2. So 1 over 3 times 3 over 2. These 3's cancel each other. So you have 1.5. So you have y to the power 1.5. Okay. Now we're not yet done, because this 9 to the power 3 over 2, we have to simplify it. So another law of indices which you need to remember, x to the power m over n equals the root of n x to the power m. So this is what we're going to apply to this 9, 3 over 2. So think of the m as 3 and n 2. So what's going to happen here is you have to get the square root of 9, and then you cube it. Okay. So the square root of 9 is 3. 3 to the power 3, 27. So x equals 27 y and a half. Okay, so we've made x the subject of the formula. Okay, because I like to use the substitution method for these equations. I like substitution method. Elimination method can be a bit cumbersome with this one. So yeah. Colleagues, any questions? I hope no one is hating the course now, seeing such type of calculations. I hope no one is saying, why am I taking this course? Hello, am I audible? Am I there? Is everyone able to get me? It's become quiet. It's become very, very quiet. Very quiet. Okay, let me just finish up so that once I'm done with the recording, we'll still review the tabulations here. Okay, so now since we've got x as the subject of our formula, we can substitute x equals 27 y and a half into equation 2. Okay. So let's do that equation 2. Let me make some space. All right, so here in equation 2, we've got 9 9x to the power half no, not to the power half, to the power 1 over 3. Where did this half come? 9x to the power 1 over 3 y to the power negative 2 over 3 equals 1. So again, this one we put this equation in a proper form. So you have 9x to the power 1 over 3 and using the laws of indices, this y to the power 2 over 3 comes down here. Y to the power 2 over 3 positive equals 1. Now, since we already have the value of x, what we're going to do is we're going to substitute x equals 27 y to the power half, which is here. We're going to substitute it here. So we do the substitution. 9, substitute x with 27 y to the power half or y to the power, not y to the power half, not 1 over 3. Y to the power half. Then outside we have the power 1 over 3 y to the power 2 over 3 equals 1. Okay, first thing we need to do, we need to distribute this 1 over 3 here, distribute it to 27 and y to the power half. So it's going to be 9 in brackets 27 to the power 1 over 3. Yes, is that a question? So 1 half times 1 over 3, you get y to the power 1 over 6. y to the power 1 over 6 over y to the power 2 over 3 over y to the power 2 over 3 equals 1. So we continue with the simplifications. So 27 to the power 1 over 3 is just like saying, what is the cube root of 27? Okay. Remember that law of indices I showed earlier? Let me just refer to it. Where is that? Yes. So if you say 27 to the power 1 over 3, if we're following this law, think of m as 1 and n as 3. So the cube root of 27 to the power 1. So the cube root of 27 is 3. 3 to the power 1 is just 3. So here we've got 9 times 3 times 3y 1 over 6 over 2 over y 2 over 3 equals 1. So 9 times 3, that is 27. So on our numerator, we get 27y to the power 1 over 6. So then y to the 27y to the power 1 over 6 over y to the power 2 over 3. Now here, I wouldn't advise you to cross multiply. Why? Because you've got two y variables here. Okay, if it's another variable, yes, you cross multiply, so you take it somewhere else. But here you've got two y variables, so we can simplify this. So if you remember another law from indices, a to the power m over a to the power n equals a to the power m minus n. Yeah, well, the board is doing that thing where it's taking long to show what I'm writing. Yes, have you seen this law here? A to the power m over a to the power n is the same as a to the power m minus n. So here, in our case here, we have y to the power 1 over 6. Let me put it separate this side. Y to the power 1 over 6 minus 2 over 3. Okay, we are subtracting these two exponents here. This one, 1 over 6 minus 2 over 3. So we go back to grade 2 mathematics. 1 over 6 minus 2 over 3 Colleagues, let's solve this. We've been too quiet and I've been speaking a lot. Let me have a break so that I can breathe. 1 over 6 minus 2 over 3. What do we get? What do we get? We have to let's be participating. Yes, Mr. Chiza. 1 over 6 minus 2 over 3. Mr. Chanda. Who else is on the chat? This is on the call. Mr. Mutanoka. Negative 1 over 2, right? Mr. Chiza, is it? Yes, negative 1 over 2. Yes. So you can write it like this: 27 y to the power negative 1 over 2 equals 1. Now again, since we've got this negative half here, so the y is going down again. Okay, it's coming back at the denominator here. It's going down again. So it's going to be 27 over y to the power half equals 1. So this is where now cross multiplication can be done here. So we cross multiply. Okay, so we're going to have y to the power half equals 27. Y to the power half equals 27. So here, remember, we want to get to our value of y. So we've got an exponent attached here, what? To the power half. So the way we get rid of it, we multiply by 2. Okay. Half times 2, that will give you 1. So what you do on the left hand side, you also do on the right hand side. So half times 2, that is 1. So you have y by itself here. Y equals 27 to the power 2, 729. 729. So we found the value of y, but x, remember, x, we haven't found its value because that x had a y on it. Okay, so to get our value of x, where is x? Okay, so x equals 27 y to the power half. X equals 27 y to the power half. So we substitute this y to the power half with 729. So we say 27 multiplied by, substitute y with 27 to the power half. So say 27 to the power half. I'm just waiting for it to show on the board. 27 to the power half. Yes, 27 to the power half. So remember, 27 to the power half is like 729 to the power half, not 27. 729 to the power half is like getting the square root of 729. So what is the square root of 729? It is 27. Okay, the square root of 729 is 27. So here is going to be the same, like 27 multiplied by 27, and you get x equals 729. So x equals 729, y equals 729. But we're not yet done because we need to know the quantity. Okay. So these 729s we're going to, yeah, the x equals 7. We're going to substitute them back into the what's this? Into that formula. Q equals x 1 to x to the power 1 over 3, y equals q equals x to the power 1 over 3, y to the power 1 over 3. So these values here are the ones that we're going to put in that formula. So we're going to say q equals x to the power 1 over 3, y to the power 1 over 3. So x and y, we're going to substitute them with 729. X to the power 1 over 3, y to the power 1 over 3. excuse me. So 729 to the power 1 over 3 is the same as getting the cube root of 729. Colleagues, what's the cube root of 729? Get your calculators, then you go. There's that symbol we can use to get the cube root. So we substitute x with 729, 729 to the power 1 over 3. And also we substitute y with 729 to the power 1 over 3. Yes, colleagues, what's the cube root of 729? As we are waiting for the calculations to show on the board. It's 9. Yeah. So cube root. So you say 9 times 9. 81. So meaning when this firm produces 81 units and they're selling them at 27 kwacha, that's when they'll maximize the profit. Yes, so cube root of 729 is 9. So 9 times 9, that's how we get 81. And you get your marks. I'm just waiting for the drawings to show on the board so that as you watch this video, you're able to see everything that was put on the table here. Yes. 9 times 9, 81. So when this firm produces, 81 units, they maximize profit.